Hey everyone, welcome back to The Explainer. Today we're jumping straight into a fantastic piece by Aaron Rose from tech-reader.blog, all about how browsers store structured data locally. If you've ever wondered how modern web apps manage to remember your complex data, your preferences, and your UI states even when you're completely offline, you are in the exact right place. We are talking about IndexedDB.
Okay, let's dive into this. We're going to start with the browser's real database, then unpack the core mental model, and see how to handle data that survives reboot. After that, we hit my favorite part, the secret power move, before wrapping it all up with the local-first architecture.
All right, part one, the browser's real database. Let's unveil IndexedDB.
You know, most developers out there know this API exists, right? But honestly, because its native, callback-based nature can feel, well, kind of awkward, a lot of folks just shy away from it. They completely misunderstand its true power. It's like people expect IndexedDB to just be local storage on steroids. But the reality, it's a completely different beast. We're looking at a lightweight, browser-native MongoDB. It's fully asynchronous. It's transactional, meaning it's fully ACID compliant. We're talking about a rock-solid NoSQL object database built right into every modern browser. It's designed for complex, structured data, not just dumping simple text strings.
Moving on to section 2, the core mental model. Let's understand the structure.
I promise you, once this mental model clicks into place, this whole API goes from confusing to completely predictable. So here's our core definition. IndexedDB is the browser's real database. It's a transactional, asynchronous, persistent key-value store for structured data. But what's really interesting here is how this sits in the wider ecosystem. Aaron Rose points out that if the File System Access API gives your app access to files, IndexedDB gives it access to state. It is quite literally the second foundational pillar of a true local-first architecture.
To master this, you really only need to wrap your head around 3 core concepts. First up, the database. Just think of it as a named versioned container. Second, we have object stores. These are basically your schemaless tables, meaning you can just toss complex JSON objects in there without having to define rigid, annoying rules up front. And third, transactions. These make sure your read and write operations are atomic and safe. So if the browser randomly crashes right in the middle of a save, your data doesn't get corrupted. Now, in practice, developers usually wrap these concepts in promises, or maybe use a slick little library like IDB to smooth over that native syntax. But underneath it all, these 3 pillars are always the ones doing the heavy lifting.
Okay, section 3, data that survives reboot. Let's map out the data lifecycle.
Think of your application data as a hero on a really perilous journey, right? It constantly has to survive the threat of browser closures and accidental tab reloads, trying to find permanent sanctuary right there on your local machine. So here's how that lifecycle actually plays out in 3 steps. Step 1, you open the database using a versioned upgrade model. Step 2, you write your data like UI state or user preferences, and boom, it now survives reloads. And step 3, you read the data back, instantly, locally, completely offline. Now, the absolutely crucial point here is that first step, the versioned upgrade model. See, the upgrade handler only runs when the version number actually changes. This totally prevents that nightmare scenario of pushing an update and accidentally breaking a user's local app. It's exactly how you modify schemas over time without ever blowing up the data your users have already saved.
And the ultimate result of all this? Reload the page, close the browser, heck, reboot the entire machine. The state is still there, instantly, locally, with zero network. I mean, just think about that for a second. There is no network hop, zero latency, and absolutely no backend is required to keep this user data completely safe. It's a total game changer.
Which brings us to section 4, the secret power move, file handle persistence.
All right, I want you to lean in for this one, because this is where IndexedDB stops being just a handy little database and becomes pure architectural magic. Let me ask you this. How do we remember files across sessions without constantly reprompting users? If you've ever built a web-based dashboard that manipulates local files, you know this is the ultimate headache. How do you make a browser app feel exactly like a native desktop app where the user doesn't have to keep granting permission to the exact same folder every single time they open your tool?
Well, here's the breakthrough. You can store the file handles themselves. Because IndexedDB supports large objects, it's literally the only place you can safely persist file system handle objects directly into the database. So on the next page load, you just retrieve that exact handle, request permission again seamlessly under the hood, and restore access without popping up another prompt for the user. This is the architectural glue between the File System Access API and a truly persistent user experience. It's exactly how your dashboard remembers which folder the user was working in.
I absolutely love this quote from Aaron Rose's article. He writes, IndexedDB is the difference between a clever HTML file that does things and a real application that remembers everything. Doesn't that just hit the nail on the head? It brilliantly captures the true transformation of your app's capabilities. It elevates your code from a simple, stateless script into a robust, memorable piece of software.
And finally, Section 5, the local-first architecture, looking at the big picture.
Let's zoom out and see how this all builds into the broader vision of a robust, offline-capable app. Just look at this recap of why IndexedDB matters so much. You get persistent state. You get full offline capability, structured storage, large object support, that massive file handle persistence we just talked about, and of course, zero backend dependency. This incredible value proposition is exactly why IndexedDB is the essential database layer for literally any local dashboard or app you're building. It is the engine that drives the local-first model.
So we've solved two huge pieces of the puzzle today, right? You have your files sorted out through the File System API, and you have your state locked down through IndexedDB. But that leaves us with a massive, somewhat provocative question. You've got all this data locally, but how do you process massive data sets without completely freezing the UI? To build a true desktop-grade application, we have to talk about performance. And that brings us straight into the realm of web workers and the Streams API. But, well, that's exactly what we'll be exploring next time. Thanks so much for joining me for this explainer. Keep building, and I'll see you on the next deep dive.